Okay, welcome back. Well, probably this question is one of the simple, uh, easiest question. The the question tried to trick you because all of them are in the probabilities, but eventually you just need to multiply them correctly. So here it's a 40% of probability, so we will write it as 0.4, 20% annual rate of return, and 20% probability rate of return of 30%, which is 0.6. And with that, we just multiply probability and the rate of return, which is 20%. So in this way, 0.4 times 20% plus 0.6 times 30%, which will give you the 26%, which is the expected value of this investment. All right. I hope you got this problem correct. And now we will move on to the probability trees. Okay. In the extension of the probability problem, so we can also have these probability tree diagrams, which can display prospective cash flows and their respective probabilities that occur in each time period. So here you can see at the beginning of the year, or at year 0, there is an investment which is $20,000, and at year 1 there is a 0.3 or 30% of chance that this project will give you $750, and there is a 40% chance that this project will generate $700 in year 1, and there is also the rest of the 30% of chance that this project will generate $625. Okay, always when we have this kind of trees, when we add them up, it should give you 1, which is the 100%. Later on, you can see also when we have also the trees extending to year 2, when we add these two, it's going to be 1, also going to be 1, and also going to be 1. So once, let's say after 30%, there is also 40% of chance if the year 1 had a $750 at year 1. There's after that, there's a 40% of chance that the project will receive or have a revenue of $1,100, and has also 600% of chance that project will generate or receive $900 of revenue at the end of year 2, and continue, so on and so forth. So that's how this probabilities can be also considered in our cash flow diagram by using the probability trees, when we know clearly the probabilities of each variable. So let's solve the problem together to see how this kind of probability tree problems can be computed. Okay, this is a very similar decision tree problem as you saw from the previous figure. This is the example from 12-5 from your textbook. The uncertainty cash flows for a small improvement project are described by the probability tree diagram in the figure. Note that the probabilities emanating from each node sum to unity. unity, and the analysis period is 2 years, and MAR is 12% per year. Based on this information, what are the E expected value, V variance, and SD standard deviation or present worth of this project? The second question is, what is the probability that PW will be negative, which is we want to know the probability that will be not economical. Third, which analysis results favor approval of the project and which ones appear unfavorable. So let's solve this problem one by one. Just as I explained the figure, the decision tree figure in the past, we have investment of $1,000 at year 0, and at the end of year 1 and year 2, we have all these possible revenues, and we have associated probabilities, and from that we will start solving the problem. First, let's solve the first question, which is answering E expected value, variance, and standard deviation. So what are the expected value, variance, and standard deviation or present worth of this project? If we convert this diagram, decision tree diagram, to the table, it will be like this. So at year 0, we have all initial investment, which is $1,000, and there is also 3 possibilities, as well as all others also has a 3 possibility. So it's going to be 3 times 3, so we will eventually have 9 different cases. So first year, you can see $1,000 minus $1,000, which is investment in the year 0. At year 1, 580, and then year 2, 1,000, which is in the first row. In the second, minus 1,000, 580, 960, and also 800, 770 to 720, 680, 760, 650, and so on and so forth. Of course, in the middle, there's a 500, and also there's a 460. Okay. So we have converted it to this figure to this table, which is in the showing all this net cash flow, and we can calculate all this present worth of this 2-year net cash flow, which is when we calculate them, we were able to find that in the first scenario, which is the most optimistic value, which is going to be $315, and later you will see at the last option will give us negative $111 for present worth. And the probability Pj can be calculated by multiplying the probabilities. So in this situation, like we multiply P2, the 0.2 and 0.3, we should be able to get the 0.06 the same way, right? We can also multiply 0.2 and 0.3 for 0.06. We can multiply 0.2 0.4, which is going to be 0.08, 0.0, 0.1, and it's going to be 0.01, 0.05, so on and so forth. When we just multiply all these probabilities, those are the probabilities that this each probability possible cash flow will occur. And same way, once we add them all, you will find that it's going to be exactly 1, which is the 100%. Okay, and now in the next column, to calculate the expected value, we just need to multiply the present worth and the probability. So if we multiply 315 and 0.06, which will give us 18.9. Same way, 283 multiplied by 0.06 will give us 16.99, so on and so forth. Eventually, we'll be able to calculate all these expected values for each probabilities. And once we add them up, that's gonna be final expected present worth of this cash flow, which is gonna be $39.56. So this is what we were looking for in terms of expected value. And then to calculate the variance, if you remember, we have to use this equation. X, which is the present worth, to the second times probability minus E, expected value, to the second, to the square, right? So to do that, px squared is these, so you just square them. 315, which is 315 square will give you $99,225, right? And also, if you square them, then you will all get these numbers: 20 squared, 400, so on and so forth. So that's the first portion, which is x squared. And then when we multiply the probability, that's what we need to calculate, right? Once we calculate the probability of, which is a pj, and the pw square, then that's this portion, which is gonna be, in this case, to get this value, 99,005 multiplied by probability 0.06, then you should get this value, which is 5,953. Okay, and continue doing that one more time. Let's pick this time to get the 302, which is pw squared multiplied by 0.06, which is the probability, right? Which will give us 302. And all the rest of the values can be calculated. It's just a simple repetition. So once you repeat all the same process, and when we add them up, that is this portion gonna be 15,227, which is this, and minus expected value to the square, so 39.56, and then you square it, and when you deduct it, then you will able to find the variance is 13,662. To calculate the standard deviation, as we have learned, once we root them, we'll find that it's gonna standard deviation gonna be $116.88. So we have calculated all the expected variance, expected value, and variance and standard deviation of this project. All right. All right. So that was answer to the first question. The second question was, what is the probability that present worth will be negative? To do that, we have to check the present worth, and those that gonna be negative gonna be case 6, case 8, case 9, right? And the associated probability is for case 6, case 8, and case 9 gonna be 0.05, 0.06, and 0.15. So when we all add them, we were able to get 0.26, which means there is a 26% of chance that we will get negative present worth, which is, considering the situation, which is pretty risky project, right? And then the next question, which analysis results favor approval of the project, and which ones appears unfavorable? Definitely the one that give us the positive result, the options will give us the favorable results, and the ones that would be negative will be unfavorable. And the analysis results that favor approval of the project are the expected value, which is the $39.56, right? And which is greater than 0 only by small amount, and the probability that present worth will be greater than 0 is 74%, which is 100% minus 26%, which is going to be 74%. So we have only 74% of chance that this project will be positive. And then the standard deviation, which we calculated, is approximately the 3 times of the expected present worth. If we go back, which was almost 116, so we can expect that the risk of this project is extremely high considering the expected value. This indicates a relatively high variability in the measurement of economic merit, present worth of the project, and is usually an unfavorable indicator of project acceptability. And I'm gonna also teach you, so we can conclude that this project is too risky, has too high variability, when we compare the expected value and the standard deviation. There's a huge portion of the project will end up with negative value, and it is unfavorable. And you will learn also you, the there's also a way to use this standard deviation and calculate the probability of uh, how much will go over the 0% or a certain number, and which is I'm going to talk about that in the future slide briefly, and you can wait for a second. But basically, there is a advanced topic that can help us to use these indicators to make a better decision. And if that was the example from the discrete random variables, also let's look at the sample question with the continuous random variables. So two frequently used assumptions are cash flow amounts are distributed according to a normal distribution, and cash flows are statistically independent. Thus, if present worth is in this formula, the expected value of present worth is going to be C multiplied by EF, and variance going to be able to calculate in this function. So you can remember this formula, which will be also in the official cheat sheet. Using that equation, we can also solve the problem. So you can see the equations are slightly different than the discrete random function. And in this example, I ask you to apply the continuous random variable concepts to cash flows over time to find the expected present worth, standard deviation of present worth for the expected values and standard deviation in the table below. So the problem already gave you the expected value of net cash flow and the standard deviation of net cash flows. If we solve that by using the equation in the previous one, right? Just calculate the convert all the values on the cash flows to the present worth at year 0, which is just 1, which is the initial investment, which is 10,000, and year 1, year 2, and year 3 for 4,000, 4,000, 4,000, 4,000, and 5,000, which will give us $1,102. For variance, we just need to multiply the variance, which is square. So PF, we given F, 8% 1 to the square, and also the standard deviation, because we are looking at the variance. So to calculate the variance, we have to square the standard deviation. So once we do that, it's gonna be like this. Also square, 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 square. Once we calculate that, we were able to find the variance as $667,978. All right. So remember the equation. CV, and to convert variance to standard deviation, it's just basically the root of 6600 666 $667 and $978, and we should be able to find the standard deviation, which is going to be $817. And we can, as I mentioned, this is the advanced topic, which is using the standard score, which is the number of standard deviation from the mean. So when we know the standard deviation and when we know the mean, which is from the previous problem, we can calculate the z-score or standard score, and we can calculate the probabilities of how much that the chance of that will occur, assuming that the chance are normally distributed. So as I have received in the past, oh, how can we use the number of standard deviation and mean to check instead of just making a very rough decision like this with knowing the expected value and the standard deviation. Also similar to what we have just found, what do we mean by expected value $1,100 and the standard deviation of $817? What do we mean by that? By using that, x, which is the putting the x is the value of standardized. Let's say what is the probability that it will exceed, for this example, like $1,000. Then we can say $1,000 divided by let's say instead of 1,000, let's say $1,500 deducted by 1102 and divide by the standard deviation 817. Then we were able to calculate certain z-score, and once we calculate the z-score, we were able to find the probability of that how much the probability that will exceed or will be within the $1,500 compared to the mean, which is $1,100. So since this is a little bit advanced topic, so I'm not gonna explain more than this, but I just wanted to let you know that there is a method which is called z-score to use this mean value and standard deviation to further calculate the probabilities that will help us to make a more appropriate decision. Okay, now I'm gonna stop the video here.